Hi, and welcome back to this, episode 34 of me mucking around with this little mini lathe. Now, as I mentioned last week, it's about time I did something with this monitor and made a sort of a user interface module and put in some sort of a housing around this area. So that's what we're going to get into. I'm going to use this jog wheel, which I got off eBay. These are pretty cheap, they only cost about 15 bucks. Seem pretty nicely made. Of course, to go with the jog wheel, I also need two switches. I need one switch with two positions to select between the X-axis and the Z-axis. You know, about 2 decades ago when I worked in aircraft maintenance, I fished this out of the rubbish bin at work. It's the cargo loading panel, and it's followed me around for the last 20 years, about the time I used it. Came from a Boeing 767. I'm pretty sure it was a service bulletin. For whatever reason, this would have been replaced with a safer, better, whatever panel. Has these beautiful switches, nicely sealed, potted, very high quality, and they've got these funky sort of paddles on them, which I kind of like, so I'll use those. So this one is perfect for X-axis, Y-axis selecting. And one of these ones will be perfect for selecting between the three increment settings. Many of the others are just momentaries. You have to hold them, so that doesn't really help me. I think that one's a momentary as well. Up here there's also a nice on-off and a second through position. I've got this aluminium U-section extrusion, so I think I'll make the actual keyboard mounting plate out of that. It's about probably 3mm thick, so it's nice and rigid. So I've just been working through the layout of everything and seeing where I need to drill holes. Probably going to look something like this. There's going to be this USB hub here to put a thumb drive into, and I need the two switches to go here. I'm kind of going for a bit of a retro look, I guess. For those of you who like guitar amps, you know, sort of a Fender silver-faced, something that sort of era. And there we have it, the finished design, if you can call it that. A bit messy, but it will get milled off anyway. Well, I think I've now got this modelled in Fixturing. I'll just go through and check the toolpath. It's going to be 5 tool changes. I've got a spotting drill, 3.2mm drill, 2.5mm tapping drill for M3, 5mm end mill, and then my drag engraver. Although Fixturing has a back plotter, as does LinuxCNC, I do like to backplot each of my tool paths here in NC Viewer, which is just a free web-based online program. Just gives me a little more confidence. It's quite lucky that this extrusion actually fits down between the T-slots. So I'll pack it up like that. First clamp the two ends, drill all the holes, and then I'll have to swap the clamps around. Now on this job, I'm not really too worried about the perfect flatness of this top surface, in the sense that All of the holes are through holes, all of the cutouts are through cutouts, and I'll be engraving with my drag engraver, which is spring loaded, so it really, as long as I can get this level within probably a millimetre, it's really not going to make much difference. There's a hole here and a hole about here, so I just have to be careful to check that out once I've got it nailed down. Wow, that's basically perfect without any adjustment. Next up here, I'm just going to probe the top surface a bit and just see just how far off the off flat this thing is. Okay, I've just gone off onto a hard e-stop. That's unusual. It should have soft stopped before it got to that position. If that's going to happen, a hard stop, Y-axis is the best axis for it to actually occur in, because MAHO put a hex screw on the end of the motor. You can wind the machine back off its stop. And I can restart the machine. Oops, that's too far. As you can see, it's about 0.5 millimetre out of level, but for drilling holes, that'll be fine. So first up, we're just going to spot drill all of the holes. Next up, we're drilling the 2.5mm holes. And now the 3.2mm holes. Well, no one would accuse that Toolpath of being efficient. It went all over the show. Now the fixturing is going to be a little bit awkward for the next bit, but I'll put a few screws in to hold the aluminium down onto the board well. Actually, I'll try to use this one. So I'll take that out and use one further away. Now the next part is cutting out all the holes and the big pocket and trimming the ends. I've been wondering how to fixture this because there's a lot of engraving going all over the place, and I've decided probably the easiest way is just bore a couple of holes, like one here and one here, and bolt it down to the T-slots through those 3 locations, because I checked the toolpath and it basically heads out around this way and shouldn't cross this area at all. Definitely doesn't cross that area. This is my homemade drag engraver. The tip is made out of carbide, just an old end mill shank ground to a 45-degree angle, and it's spring loaded. Now I'm just going to touch this off. The drag engraver unfortunately didn't cut that evenly in this very soft extruded aluminium. I probably also should have put some WD-40 on there first as a lubricant. So I'm going to run the toolpath again, this time with some WD-40 on it. Yeah, drag engraving's really not as nice as rotary engraving. As long as I've only got the standard spindle on the MAHO, which only turns at 4,000 RPM, that's really too slow for rotary engraving. I mean, I have done a little bit with it, but it just takes forever. Well, there it is. As I say, it's not perfect, but seems pretty legible, and yeah, I'm quite happy with that. It's kind of cool. Whoops, I just realised I forgot to turn my microphone on. Oh well, or was it just tapping holes? The 3 holes on each end are going to be used to rivet a piece of angle aluminium too, and I want to countersink those for aircraft rivets. Did I ever show these before? These are microstop countersinks. I got this from Boeing Surplus up in Seattle. They're kind of cool. They have a left-hand thread down the bottom here, and then a collar that's spring-loaded, and inside there's kind of a spline, so you can adjust the thing and then lock it. And then out the front here, the actual countersink itself, which is 100 degrees with aircraft rivets, is replaceable. It's got carbide inserts. Just a really cool piece of equipment. You know, you set it up for exactly the right depth of cutting. You can do thousands and thousands of holes without having to reset it. They had a huge bin full of them. Don't know what's wrong with them. I can see nothing. So I bought 4 or 5 of them in all different sizes. Well, these flanges are a bit long, so I need to trim them down on both sides. Obviously I've got an issue with the edge distance on this top right hole. Yeah, luckily it's not structural, otherwise I have to do it over again. Alright, let's nail this together, shall we? These are AN 426 aircraft rivets. Using my rivet squeezers. Whoops, that's a bit too flat for an aircraft job, that one. Over squeezed that a bit, so I'll just adjust the squeezer back. But it's a super fast and effective way of joining metal. Well, the first countersink, I think I might have got that slightly too deep. In fact, I did get it slightly too deep. Oh well. Lucky we don't have to fly with this thing. And there you go. There's one end done. Now I don't think I can squeeze this side. This is a piece of steel which I got from the scrap yards and I surfaced with the mill, so it's pretty decently flat. I'll just flip this over and we just drive that from the back. Called back riveting. That'll do it. This next corner still wants to spring up a little. So what I'm doing here is just spreading the rivet a bit and then drawing the skin down. try and close up that gap. This looks good. So next up, using some nail polish, I'll just fill in all our engravings. See which one of these is thicker. I was given instructions to use the thicker one. Nail polish isn't really one of my big skills. It's a bit of a shame that that drag engraver tore out metal so badly in a couple of positions there. Well, I think it's about time we start assembly, huh? First up, this keyboard, I've had a number of people ask about it. I found it used on eBay Kleinanzeiger in Germany, which is kind of like Craigslist for Germans. Model is the PC Mini 5, and it's made by the company Kundisch. I mean, I'm guessing it's probably ancient. One of the videos I did, I showed how I butchered the cable for this to be able to use it with a modern USB adapter. Next up, we've got the encoder. You go looking on eBay for, I think, jog encoder or something like that was the search. You find these, they were about 15 bucks. Nothing special. Those are very satisfying switches, very nice. Well, there we have it. That's the finished control module. Now I just need to install it, wire it all up, and get all of these things configured. But I think that'll be a task for next week. I'll go and get this video edited and uploaded. Once again, thanks very much for watching, and I look forward to having you back next time.